Alright, this is going to be the start of chapter 4. And chapter 4 deals with energy, but first we're going to talk about work. Now, in order for work to be done in the scientific sense, we must have a force that moves an object. And then we would be, if we have a force that's moving an object, then we're doing work. And energy is defined as the ability to do work. So if you have energy, then you can do work. And when we talk about energy, we usually have two forms. We have potential energy, and this is stored energy. And this could be the kind of energy that you would find stored in a battery. This could also be the kind of energy that you would have stored up in food. And the second kind is kinetic, and this is energy of motion. So whenever something is moving, we're going to have kinetic energy. And the kinetic energy equation that we use is 1/2 mv squared, where m is the mass and v is our velocity. So the more mass that an object has and the more velocity, the faster it's moving, the more kinetic energy it's going to have. And when we label energy, or when we talk about units, I should say, units or the label, we could use joules, or the other unit is a calorie. And 1 calorie is 4.184 joules. And you could use that as a conversion factor then to go between joules and calories. Now we want to make sure that when we talk about foods, we're using the dietary calorie, and the dietary calorie is a capital C, and these are actually kilocalories. So these calories are very small. When we talk about foods, since we need a lot of energy from our food, those are actually in kilocalories. So the dietary calorie is actually kilocalories. And in your textbook, they have a page in here that gives you the dietary calories, and you can see they're kilocalories. They've also given them to you in kilojoules. So the two different units, calories or joules, except this is kilocalories and kilojoules. So they've given you several different kinds of foods and then how many calories you would get out of those. So that would be the potential energy that is stored in the food, and then you would eat the food and then your body can use it to make you move, and that would be your kinetic energy. Okay, temperature. We usually think of how hot or how cold, but temperature is actually the average kinetic energy of the particles, which means the faster the particles are moving, that means the more kinetic energy they have, and therefore the more temperature there is. And whenever you have two objects that are in contact with another, then energy is going to flow, and that is what's called heat. And that's the energy transferred from a high temperature object or an environment to a low temperature. Okay, next we want to talk about radiant energy. And radiant energy is basically light. And light can travel as a wave or a particle. It's actually a dual nature, meaning it has parts of both. But when we talk about light, there are 7 main kinds of light. We have radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. And your visible, this is your Roy G. Biv. So your red, orange, yellow, green, blue, indigo, violet. And before red is infrared, and after violet comes ultraviolet. And when we talk about here microwaves, this is not what a microwave oven uses. Your microwave oven uses heat energy to cook the food, so it's actually using infrared. It's not using microwaves. Microwaves and radio waves are both used for communication. We have either shortwave or long wave. Infrared, you've heard of like infrared goggles that we can use for night vision. Ultraviolet, we know that that's what we can get from the sun, and there's 2 different forms. We have the UVA and the UVB that can damage us. X-rays, you're familiar with those for medical applications, and then gamma rays are used to treat cancer. When we look at these, they are only ranked, so in terms of a way that we could describe them. And as we go down, we have increasing energy. So gamma rays have more energy than radio waves. And as we go up this way, we get a larger wavelength. So if you think about a wave, this would be the wavelength. So radio waves have a much larger wavelength than do gamma rays, and gamma rays have more energy. And there is a diagram in your book that looks at radiant energy, and it breaks, you can see your violet down to your red, and it shows how that's the part of the visible spectrum, the part we can see, and then what the other ones are for. Now the chart that I have given you is just backwards. I started with low energy and went to high, where this one goes from high energy down to low. Alright, that's going to be the portion on energy.